This is question number 48 of GATE 2017 Metallurgical Engineering. Steel component is subjected to fatigue load with sigma maximum equals to 200 megapascal and sigma minimum equal to 0. The component has an initial crack length of 1 mm. Propagation of crack is governed by this relation, right? Now, where the crack length A is in meter and N is the number of cycles and delta K is in megapascal under root M. The length of crack in meter after 1 million cycles will be, right? So we have to calculate the crack length after 1 million cycle. So to learn the concept related to fatigue failure of materials, you can refer lecture number 27 part 2 from the course Basics of Materials Engineering by Professor Ratnakumar Annavatula from IIT Madras. To solve this, first of all, we have been given this relation dA upon dN will be equal to 10 to the power minus 12 delta K cube. So this relation is nothing but we call it as a Paris law. So this is given by a famous scientist Paris, and we call it as a Paris law, right? So here there are different variables which is given: crack length, number of cycle, the value of delta K, right? So how do we in our case, what are the things which we know is we know the maximum value of load, which is sigma max 200 megapascal, sigma min which is 0, and initial crack length, let's say it is AI, which is 1 mm, that is 0.001 meter, and the value of number of cycles also is given, right? So number of cycles, let's say it is denoted by n, 1 million, that is 10 to the power 6 cycles. So these are the things which we have been given. So first let's understand what is the delta K. So delta K is nothing but maximum minus K minimum, and this K max and K min basically it is related to the fracture toughness delta K. So the K max is given by sigma max under root pi a, and K min is given by sigma min under root pi a, right? So in other words, you can write delta of sigma under root pi a will give you delta K. So this is the relation between delta K and delta sigma, and delta sigma is nothing but what? Delta sigma is our sigma max minus sigma min. Sigma max is given as 200 megapascal and sigma min is 0, so delta sigma is nothing but 200 megapascal in our case, right? Now we'll come back to this relation which is given by Paris law. So dA upon dN is 10 to the power minus 12 delta K cube. Delta K is what? Delta sigma under root pi a cube. So we will rearrange this equation. So dN equals to dA by 200 under root pi a to the whole cube, and this 10 to the power minus 12 will come below, and finally it will give you 10 to the power 12, right? So now we will further simplify it. dN equals to 10 to the power 12 upon 200 root pi to the whole cube dot dA upon a to the power 3 by 2. Now we have to know that after 1 million cycle what will be the length of crack. So what we need to do is we have to integrate from 0 cycle to 1 million cycle, that is 10 to the power 6, and this will be equal to 10 to the power 12 upon 200 pi under root whole cube into integration of a to the power minus 3 by 2 dot dA from crack length. Initial crack length we have been given is 1 mm, that is 10 to the power minus 3 to the crack length of, let's say it is A. So from 10 to the power minus 3 to A we have to integrate. So this will give us dn, integration of dn will give you n, and if you put 10 to the power 6 minus 0, it will give you 10 to the power 6. It will be equal to 10 to the power 12 upon 200 under root pi to the whole cube into integration of this will be nothing but a to the power minus 1 by 2 upon minus 1 by 2, and this will limit will go from 10 to the power minus 3 to a. So if you simplify this, 44.54 equal to minus 2 by under root a plus 2 by under root 10 to the power minus 3. So from here you can get 22.27 equal to under root 1000 minus 1 upon root a. So from here if you simplify, then we will get 1 upon under root a equal to 9.35. So from here the value of a will be equal to 0.011. So the value of a, that is crack length in meter, is 0.011. So the right answer for this problem is 0.011 meter. So that is the correct answer. Thank you.